All right, so we are trying to expand this logarithm thing that we were given. So we've got log of, yeah, a whole bunch of junk. Okay, so what comes to mind?
Log rules?
Okay, so I'm probably going to use some log rules. Which one comes to mind maybe first? Yeah, the log rule about division. So one, does that apply in this case?
Cube square is divided with other thing.
Okay, so this stuff is divided by that thing, right? So I should be able to rewrite this using the division log rule.
Or you could call it multiplication, like or use division and multiplication to do it both.
Yeah, let's just handle the division first, maybe. All right, so what do I get when I apply the division log rule?
Get log of the quantity x plus 1 cubed times quantity y minus 2 squared. And then that's the end of log divided by log minus log quantity is equals 4 to the
Okay, cool. So that really is, I had the log of a top over a bottom, right? And I use the log rule to say that's the log of the top minus the log of the bottom. Okay, now what?
You can do the multiplication one.
Okay, we can do the multiplication one. So we apply the multiplication log rule to what?
Log x plus 1 cubed times y minus 2 squared.
Okay, so we get log of,
the quantity x plus 1 cubed plus log of quantity y minus 2 squared minus the log of quantity z plus
cool. All right, now what?
Put the powers in front of the log.
Okay, so what rule are you using?
I don't know the name of it, but
Describe it for me. It's the
isn't it the no,
it's the log
So-
rule about powers, right?
just powers, okay.
I mean, that's how I would describe it. I would say it's a log rule and it's the one about exponents of powers. Okay, so that's these guys drop down front, right?
Yep.
Okay, so really that's applying the power log rule 3 times, right?
Mhm.
And what do I get when I'm done with that?
3 log x plus 1 plus 2 log y minus 2 minus 5 log z plus 4.
Okay. Now what?
I think you're done.
Why can't I use the multiplication log rule on like this guy, that guy, and that guy? Or maybe the multiplication rule on these two and the division rule on that one?
because the number in front of them is the same and you just didn't have the backwards of it anyways. So why would you want to do that?
Well, because there's addition logs. Isn't that, can I make that log of x times log of 1?
It's a false log on it, right?
Yeah, that's me being an idiot, right? That's, I'm trying to reverse a log rule, right? Or I'm trying to kind of rearrange a log rule. If it's not one of the 3 that's written in the book, it's not quite the right thing, which means that it's going to break the world if you do it, okay? So don't do that. It's
Yeah.
crazy. Doesn't work. So this is, in fact, as good as you're going to get, because there's no multiplication, division, or powers left in the, what do you call this thing? we ever used this word? Starts with an A. I think it's called the argument. It's the input of the function, right? Really, this is, I'm inputting x plus 1 into the rule logarithm. Right, so there's no powers multiplication or division left in my inputs. Cool? Where were you stuck, Megan?
I don't know, no, I just couldn't. Probably just what you needed to do.
Yeah, maybe where to
Yeah.
start. Yeah, so with these, start with the kind of biggest thing. And on this, the biggest thing to me is I've got a log of a top over a bottom. So I'm going to start by breaking that if I can. Cool?